to Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. This is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany, bringing you yet another interview today. Today I do have Giuseppe here with me. Hey, how you doing?
Hi, Jan. Nice to meet you. Thank you for having me here.
It's totally my pleasure. A little disclaimer here. Today we do the first interview on my new computer. I was building Startuprad.io on a laptop that was first produced in 2015, and now I upgraded it seriously to a computer together with a friend who actually called the computer only the Beast. So let's see how this is performing and if everything works. I actually have not all the cables yet, so that means I'm working only on one monitor, but I'm sure
I keep my fingers crossed so that everything goes well.
Yeah, in Germany, thumbs pressed, but we do both that and everything will be totally fine. Today's episode is sponsored by Startuprad.com, the fastest and most efficient way to find new investors, startups to connect, and cooperation partners. Giuseppe, you are an Italian living in Munich. Funny note here, I've heard a lot of people from Munich referring to it as the most northern city of Italy.
Yeah, exactly. So Munich is seen as the most northern city of Italy. It's because of the climate, because of the... No, it's really nice to be here. It's very close to Italy, as you know. And the atmosphere, the way of living is quite similar. And except the food. So the food we had to import.
So you're not a fan of Weisswurst for breakfast?
Not really. Maybe once a year I have Weisswurst, but then I go back to my Italian dishes, gnocchi and tagliatelle. And, we have good food. We have a big variety there.
I have to admit that they both have a certain place in my life, but actually don't tell anybody, but I prefer Weisswurst for dinner.
Okay, don't tell anybody. This would be a crime in Bavaria, so don't do that.
Exactly. Giuseppe, you are today here because we will talk about a serious topic, diagnosing tumors, speeding up this diagnostics. You are from a company called Vivascope. Can you tell us a little bit about this company and the history? Because when we talked before, you told me about a very, very interesting setup here. So you're not necessarily a startup anymore. You do your R&D in Rochester, upstate New York. You're headquartered in Munich, and you have production facilities in Europe and the US. So can you walk us a little bit through all that stuff?
Yeah, so the whole story, I mean, I'm now 19 years with the company, quite a long of time, but it started even before, and it started with the in vivo application. So today we will hear a lot about in vivo diagnostic and ex vivo diagnostic. In vivo diagnostic was the first area of application. And it's quite interesting how it started. They developed a product which was supposed to check the effect of hair removal, which is a pure aesthetic application. And they wanted to see how good the quality is when you remove hair, how good the quad cutter is. And then they realized, wow, we can see much more in the skin. We can see cells. We can see different layers in the skin. What can we do with this information? And then they started to investigate, and by now we can use this in vivo technology, which had its origin in aesthetic, to diagnose very accurate skin diseases in vivo before cutting out anything. Okay, this is how it started. The other technology we are offering is ex vivo. This is I have to remove tissue, and here I want to have a very fast diagnosis. This is a bit the history here.
We may get into the background because we're talking today about diagnosing cancer, especially skin cancer. And everybody who's thinking, fast diagnosis, you get a good diagnosis anyways. But actually, guys, listen, when you get tissue removed, you want to have the results as fast as possible to know if it's in cancer or not. Right now, how long can it take to get the diagnosis?
It takes, unfortunately, quite long, 10 days up to 3 weeks, and this is far too long. I'm not a doctor, I have a commercial background, but I was quite shocked when I started in this area to see how long it takes to get a result. So today I can order whatever I want digitally in the internet. I can get it the next day. But if I want to know if I have a tumor or not, I need to wait so long time. And then I started to try to understand why is this? What's the reason for that? On the other side, when we talk about skin cancer, so we're going to talk today about in vivo application, means skin and all diseases around skin, and the ex vivo application with the other device, it's all type of tumors, from prostate cancer to breast cancer, lung cancer, and so on. In the area of skin, there is an over excision rate. Let's say there is a lot of biopsies done which are not necessary. So over 60% of this removal are done because there is a suspect. But skin, I can look with my eyes, I can use a lens, but I always stay at the surface. I see the top of the iceberg. I don't know what's below, what's happening. How big is the iceberg? Gonna crash or not? So it's the same for skin cancer. We have the difficulties to understand, or the dermatologists have the difficulty to understand what's happening below. Before risking to get a melanoma, they just remove it. But then, after 2 weeks, you get the result was nothing, was a benign lesion. So in the in vivo area, we want to avoid that too much biopsies are taken and benign lesions are sent to the laboratory. Yeah, this is the aim for the in vivo. Ex vivo, we want to know immediately what is there. In the best case, this is our target, which we're managing, when the patient is there in the hospital. Yeah, that's very important.
You're talking about unnecessary biopsies. We may tell our audience a doctor is not really able to tell from just looking at it if it's cancerous or not. So that means that needs to be some tissue removed, sent into a certain laboratory, and then really thoroughly cut under a microscope, and they have specialists to look at it. And I do believe that's the process when you guys come in, right?
Yeah, exactly. So every tumor in the world needs to be judged by this doctor called pathologist. Yeah? The pathologist is the only one which can tell if a tumor is there, independent if it's skin or the other types of tumors. The process, the base of his judgment is an image. And the image is now achieved by a process called histology. Unfortunately, this process called histology to get the image is today in 2024 an analog procedure. So tissue is removed. There are 3 types of these procedures. So the most common one was the paraffin section. I don't know how deep I should enter into these details. Paraffin section is one of these. It takes minimum 24 hours. Here they take the tissue, they embed in paraffin, they cut it in slices, and then they put it into chemicals. And then 24 hours later, they have an image, which is on a glass slide, and the pathologist is looking at it. Since ever there was the wish to have a faster way of doing diagnosis, of doing histology, of getting these images. And in 1894, the so-called frozen section was invented. Here we have the advantage that it takes less time, but the tissue is frozen, cut into slices, analog, and then put into chemicals. This freezing up the tissue creates some problems. It creates artifacts. And every time I cut something and I put into paraffin or frozen, I lose the tissue, I lose the probe because it's dead. I cannot use it for further investigations. And this is the problem of the current system. It's still made in an analog way. What we do is we do it digitally. In vivo, we image the skin in a digital way, and we see what's going on, if there's a need of excising or not. Ex vivo, we have a tissue which we just put on the machine, we scan it, and we get an image like the pathologist knows today. This kind of H&E-like image, it's called. Big advantage, time. I preserve the tissue. I can act much faster than with the analog system. And we're talking here about minutes. So it's not a small change that you improve by a bit. It's from weeks to minutes. And that's a big improvement. The other problem we have today is that worldwide we have 20 million cases of cancer, which need to be diagnosed by whom? You learned the lesson?
Pathologists.
By the pathologists. So the number of cases is increasing in a drastic way. We're expecting in 2040, 30 million. It's not saying me, it's the WHO saying this. And on this number of pathologists which are able to make a diagnosis, I would expect also a big increase. But here's the problem. Worldwide, we have 84,000 pathologists covering 90% of the cancer cases. Yeah, this is a far too low number. And the tendency is a decreased in number of pathologists and not increased in number of pathologists. It's a huge problem. Yeah. So when we have more and more cancer cases, less and less pathologists, who's gonna diagnose all these cases? Means if I'm lucky, I get my result after I don't know how many months. If I'm not lucky, I will die before I get my diagnosis. And here we need to change things. We need to make the process much more efficient. I cannot bake pathologists, but I can make this analog process in a digital way, cutting down the time and reducing, reducing the time needed to get to the diagnosis, to get to the image. Yeah.
We may add here that, of course, for everybody who had ever a biopsy done and it was not yet determined if it's cancer or not, this is quite a stressful time. But we should also emphasize that this could give you a week's head start in the best case to start your treatment, which may at the end have a decisive impact on your treatment. So that's where you guys are really coming in.
It's amazing. Just tell you a story. I was last week in Rome at our reference center, Unicampus Biomedico, with a fantastic pathologist, Anna Crescenzi. She's a wonderful progressive doctor. And I assisted to a procedure. So we had a patient, a suspect of pancreas. You know, pancreas is very, very aggressive. We have a mortality of 95% in this area. He came in. Then Professor Di Matteo used the endoscope. So he took anesthesia, of course, endoscopic examination. We took a biopsy, which are liquid biopsies in this case, not firm. And then immediately they brought it to the machine. They scanned the probe. And within 3 minutes, we saw that, number one, what they took out of the body is of good quality. That's also a challenge when I cannot see this immediately. And number two, we saw that it's an aggressive tumor. Yeah. So very bad for the patient. Normally now, this probe would have gone to the laboratory. After 2 weeks, he would get his result. And then there's another process called molecular analysis in order to know what kind of treatment you need. It would have taken 4 weeks until he can start the treatment. On this day, I was quite flashed because I saw there's an aggressive tumor. She then took the probe and scraped a bit of the cells into another container and put it in another device. And the molecular analysis was done within 3 hours. So within 1 day, this patient got his analysis, aggressive type of pancreas tumor, and he got also the therapy he needs, the information that is needed to start the therapy. This is a revolution. This is a change of paradigm. It's like when they invented the plane, not the car. Yeah? It's changing completely the workflow, cutting down the time from weeks, in this case 4 weeks, to 1 day. And for me, this is emotional. Yeah, this is very, because everybody which has a case in the family can understand what the problem is. Yeah, many people out there don't even know about this time needed to get the diagnosis. They trust the system. The system is relying on an analog system. But I don't want to wait 10 days. Do you want to wait 10 days if you have a suspect of pancreas or lung biopsy?
No, I wouldn't want to wait that long.
It is incredible that we don't know, and we realize once we are affected, or once our beloved are affected, or friends are affected, we realize, wow. And there is an urgency because the situation is not getting better; it's getting worse. So it's not saying us. The prediction of cancer is increasing in a drastic way, and the guys which can tell you there's a cancer are decreasing. There are 40% over 55 down the way of retirement. Yeah, the workload is increasingly high of the remaining people, and especially in Germany. I just read yesterday, it's one pathologist per 48,000 inhabitants, means the worst value in Europe. In Germany, I would expect not Germany. Yeah, so there's even worse situation in this country, but it's in general. We have some differences in the distribution, but in general, worldwide, we have a big problem.
I see. And when you've been talking about this biopsy, by the way, liquid biopsy is just that you don't extract tissue but liquid, so simple as it gets.
So today there's the tendency, which is good, to be less and less invasive. So in the former times, they took big chunks out of your body. They had a big probe, yeah, big tissue in order to make the process. Today, when I have suspect of lung cancer or pancreas or thyroid, they try to go with a nice needle and take some sample, very little sample. Yeah. So imagine this system, this analog system, which was built based on big chunks, has to handle these small little samples, and this is quite impossible. There's there's no way to do a fast diagnosis with this analog technology. It takes time. It needs to go to the laboratory. The patient goes home. So there's a process. After 2 weeks, they find out, this biopsy was not good. Please come back, which is the worst case. We have to do it again. Or after 10 days, we did the process, and you have, unfortunately, tumor. We need to treat you. Yeah. So for us, as we use it like a scanner, it's very easy, to have liquid biopsies or small fragments of biopsies. So we see that in the market, or let's say in this area, there's an increasing number of small and liquid biopsies, which is good for us. But the more we have these minimal invasive biopsies, the more that the current system is challenged. So we have the advantage of, you put it on the scanner, you scan it, and then whatever it is, whatever size it is, we can see it immediately. So this is another big advantage. And there's a funny story. How did we get there? How did Anna Crescenzi get there? We went for a neurology congress in Rome before COVID. And then we did the congress. We all flew home. And then COVID started. And we had no access to this machine anymore. And Anna was in this hospital, and she also at that same time got a little sponge, a little matrix, in order to bind these little and liquid biopsies. So thanks to COVID, she had the time and to test this solution and to find out that there is a new way of having a fast evaluation, a digital way. So this is also some positive aspect of COVID. So this 2 years where she had the machine, she managed to develop all this application, which is fantastic.
Mm-hmm. When you've been talking about getting faster digitally, the first thing that came to mind, you got less and less pathologists, and everybody is talking about AI right now. I do totally understand that there are much higher levels of certainty, of trust, of testing, of processes that need to be done before you could even think about introducing even an AI assisted diagnosis for pathologists here. My question would be, are you guys already working on stuff like that?
Yeah, we need to. I mean, it's obvious. We will not change the number of pathologists so quickly if it's not a political change, a push. But even so, if somebody would decide today to invest in the promotion or let's say in the education of new pathologists, then it would take years. We will need AI because even we make the process fast and digital, there will be we need to support the pathology in the daily work. Thanks to the fact that we do it digitally, we have now the possibility with the digital image to feed AI system. We did this with our partner university and Professor Hartmann from the LMU in Munich for BCCs. Is the most current skin cancer, the so-called white skin cancer. The black skin cancer is called melanoma, and she won with our device, with the software, the first prize, the German Medical Award. So it was a nice moment for us. But this is only the beginning. We have now also developed together with another company an AI judging the sample. So I want to know if I take with my endoscope out of the body, the biopsy is good of quality or not. And here AI can help us immediately to check the adequacy. Yeah. The next step would be to check adequacy and to make a kind of preliminary diagnosis to support the pathologist, or to indicate where the area are. Yeah, you could see very nicely where are the cells which are important. Are they there? Are there enough? So when we talk about biopsy, it's important to have a good, adequate probe, means enough cells that I can use to do all the consecutive examination. The first one is histology, to understand I have tumor, I have not tumor, is it aggressive or not? The second one, which they adopt, is the immunohistochemistry to better understand the typology of the tumor. And the third one is the molecular analysis to know which therapy is fitting to you or to me, Giuseppe, or to my sister. So we are all different. So we need individual so-called medicine. We need to have individual treatment. Yeah, not everybody can have the same treatment. It's impossible. It's not efficient. It can be good.
The most efficient treatments the doctors are talking about, you have a certain molecular composition of tumor, and then they have treatments, they call it a key, it fits in the lock, and then they can really efficiently treat it. That's what you're talking about, individual medicine, right?
Yeah. So we need for every individual, I'm receptive to type A, you're receptive to type B because of the DNA. And then you need the drug made for type A or made for type B. So what Anna told me was very interesting is today, when you do the normal way, you have a suspect of lung cancer, for example, you go make the investigation, the imaging, then they take the biopsy, goes to the laboratory, and they see it's an aggressive tumor. They have to do a molecular analysis, and it takes 4 weeks, 4 to 5 weeks. So what do they do with the patient in between? They cannot wait 5 weeks doing nothing. They start a general treatment, which has a cost for the system. Imagine 1 month of treatment for lung cancer is 60,000 euros in cost. So they just start a general treatment to do something in the hope it's good until the specific result comes where they can use the right drug. The problem is that you cannot stop after 4 weeks the general treatment. You need to finish the cycle, she explained to me. You have to finish until this is then ready, and you can then start, in some cases, after 6 weeks, the specific treatment, which is crazy. I mean, we lose time. We spend resources on a drug which doesn't make sense, and then we put in danger the life of the patient. She said some patients cannot wait all this time and they just die. It sounds terrible. Yeah, I say this, but if you think about your relatives, to say he died because it took too long to get the diagnosis, how crazy is that? This is really something very serious. Yeah? Independent that we are working in this field, but it's just crazy to say he died without knowing what he had, or he died because it took too long to get the diagnosis. So there's an urgent need because of many reasons to improve the system, to digitalize the system, to have digital images which can be seen remotely and not on site. There are some countries where the pathologist is driving by car. By car, is driving to a clinic to assist during a surgery process. How crazy! Why? It's I don't have to say it's nonsense. Yeah. So it's a waste of resources which we don't have.
Mm-hmm. You guys are really making effort to shorten the diagnosis and establish even a better diagnosis with helping with remote. So my understanding is in the future, there will be options for remote. In the future, there will be options for AI. Are you also looking for, before we get into a little bit into the future, where are you guys currently available? Because as we already said, you have the headquarter in Munich, you have R&D in upstate New York at the Great Lakes. Have you been there? Did you wear warm socks?
In the wintertime, wintertime is quite tough in Rochester. I think due to the climate change is also a bit changed there. But I remember flying to Rochester from Newark by this little propeller plane, and a stormy night, and I see only the runway from the cockpit was open, the door was open, and you could see the snow and the plane, and he was like doing like this, and in the last minute doing like this, was crazy. But summertime, Finger Lakes, wineries, really fantastic. One time I had the luck to fly via Toronto. I took the car and I passed Niagara Falls, and then drove on to Rochester. So beautiful area. Especially the Finger Lakes is fantastic. I love it. I love it very much. This is a nice area.
I would assume you guys are Vivascope is currently available in Europe, meaning the European Union and the United States. Anywhere else?
We just started in India. It was an idea which came into my mind. Why not India? It's 1.4 billion people. And we hired Indian colleagues, which I appreciate very much. And we did our first demo tour. And after the first demo tour, I think the Indians are really amazing. Yeah, they got so excited, so progressive doctors, and they have a big problem. They have even higher workload than we have, and they immediately ordered 4 devices. Now it's after 1 month. So this is, for me, it's wow. They are fast. They are clever. We need to learn a bit of the speed and dynamic of Indian people. In Europe, we have 50 centers by now. The latest one is really made me happy. Is a pediatric center in Ancona, means for babies and children, because I didn't also not know that sometimes when you have this Hirschsprung disease is called, you need to do a kind of surgery, and the babies are put under anesthesia for quite a long time. So we could reduce the time for anesthesia by 2 hours, which is immense. This makes a big difference for the babies. Yeah. So I think this is a fantastic application, and I just got the news that the first oral lecture was accepted at the World Congress for Pediatric Oncology. I think we all wanted our babies, our children are feeling well, and that they get the best treatment. We have 50 centers throughout Europe. We have roughly 5 now in US. US is quite tough with the regulation. You need to prove by big studies that you are allowed to do this. So we have MD Anderson Memorial Sloan Kettering, New York, with fantastic scientists and doctors. Professor Krishnamurti, Savitri, she's a pathologist, very, very progressive. Manu Jain, pathologist. So it's nice to see how these pathologists are pushing the technology. So it's nice because pathologists are used to this analog process, but they saw and they understood that this is a help for them. It's a relief. They can sit at big monitors, they can judge the sample from the office or from home, and it's not a threat. We're just changing the way of doing histology. We do it digital. And funny enough, when I started my first job at the Japanese company at that time, we were the first introducing the digital camera. So before we used the camera with the film, so we made pictures, we took the film out, we sent it to laboratory, we waited to get the results. And now it's basically the same also in this field, in a much more important field, the pathology, histopathology, the diagnosis area. So it's nice. It's nice to have this kind of repeating of the history in a higher level, let's say.
I see. Are you guys looking currently for somebody to join your journey? So are you looking for talented people?
We're looking. It's getting more and more important. We need, of course, it's kind of a challenging. You need to know a lot. As I mentioned, I studied MBA, but I had to learn a lot about skin tumors. What is a melanoma? What is a basal cell carcinoma, actinic keratosis, inflammatory diseases? What is the prostate cancer? Why they take 18 biopsies out of your prostate to know if you have prostate cancer? Breast core biopsy, fine needle biopsy, fine needle aspiration, lung. How do they do this? So it's a lot. It's really a lot to learn, but it's a fantastic way to combine your job with something really makes sense, which helps in a tremendous way. It helps to improve and to get fast results, and it helps you, it helps me when I'm affected, and the probability to get the cancer is unfortunately increasing. So we have to think about, if it happens, where do I go? Do I go to a center offering old type, or do I go to a center offering this digital, new, progressive approach? And on the one side, we're looking for talented people. Of course, we are a middle-sized company. We are not Siemens. We are not General Electric. So it takes more time, it takes more resources, and let's say we need then to just do it all by ourselves. Thanks God, we won many grants last year, which allow us or supports us. But medicine is a very slow-moving object. To change things takes long time.
Yeah, I do understand that some of it is just to reduce the risk of potential misdiagnosis. Are you guys are also open to talk to new investors?
Of course, always. I am a firm believer of collaborations in terms of combining different technologies together, in terms of bringing people with knowledge, insight, in terms of bringing resources to speed up the process, because, as I mentioned, it's an urgent problem, and the more power we have to change things, the more let's say, the more we have the chance to also save people. Here we're talking about people's life. That's definitely an issue. And we now have a lot of big companies knocking at the door. I'm quite happy, and I'm looking forward to these new collaborations. But our doors are open for more.
Giuseppe? It was really great having you as guest. You could totally tell you are an Italian the way you've been talking.
Sorry,
I like it when I do have a guest who has really an interesting and important topic and can talk a lot about it. We're now running almost at 35 minutes recording time here. So I would like to say thank you. Mille grazie.
Grazie mille per l'invito. I hope it was a bit interesting. I tend to not stop. I was warned, please stop. So thank you so much. It was great to talk about this problem and possible solutions. And I wish you fantastica giornata e settimana. Ciao.
Ciao.
Ciao, ciao. Ciao, ciao.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.